So calculate the surface area of objects formed using right rectangular prisms. So basically boxes. Calculate the surface area of shapes, objects that are box prisms. Okay, so the method we will be using is to calculate each face and then doing the sum. More specifically, the method that I'm using is called front, back, top, bottom, left, right. Well, what do I mean? So let's say I have a box. So this is a box in 3D. So I'm just doing a little bit of perspective here. Now here you would see three faces. You would see the top. You would see the front. And you would see the right side. Now, there are three other faces which I cannot see. In this point of view, I would have to take the box and turn it. But I know that the bottom will be the exact same as the top. So that's why I always group the top and the bottom together. And the back would be the exact same as the front. So that's why we're always going to group the front back together. And the left side, which I can't see over here, it's going to be the same as the right side. So that's why we're going to use this method, top, bottom, front, back, left, right, and we're going to calculate the surface area of each, double it, and then we're going to do the sum. The sum is we add them all together to find the total. So that's the method we'll be using. So first example, we have a 3D shape here, and we have to calculate the total surface area. So we'll be using the method that I stated above. So front, back, top, bottom, left, right. Right. So let's start with the front, back. So if I were to look directly in front, I would see this face, this face, this face, and this face right here. More specifically, if I were to draw that into two-dimension form, I would see this. I would see the three faces on the bottom, plus I would see the extra face on top. Whoa. I would see the extra face on top. So that's what I would see. Now it says here that each side length is 2 centimeters, meaning that that's 2 and that's 2. So each face is a square, but they're 2 by 2. So each face has an area of 4. So this one also has an area of 4, also have an area of 4, and this one also has an area of 4. So the total surface area of the front would be 4 times 4, 16 centimeters, and because it's a surface area, there's 2 dimensions, it's squared. Now, this is the front. The back would be the same. If I were to look directly behind, I would see the same shape. So I just double that to get 32 centimeters square, and that is the front back. Now let's take a look at the top. So if I were to look directly above, I would see that face, that face, that face, and that face. I would see 4 faces. So I would see the top 3. I would see that one, that one, that one. It would look like that if I were to fly a plane and look directly above. And I would also see the one here sticking out. And again, each face is 4 because it's 2 by 2s, square faces. So the total surface area of the top would also be 16 centimeters square. And the bottom would be the exact same, so I double to get 32 centimeters squared. Finally, I'm going to look at the left side and the right side. So if I look at the right side here, I'm going to see that face, and that face. So what I would see if I were to stand here and look directly at the figure from the side, I would see only 3 faces. I would see the 2 faces on top of each other, plus I would see one sticking out. So I would kind of see like an L shape. And again, each face is 4. I would see those 3 faces, and so the total surface area would be 12 centimeters squared. And I doubled that to get 24 centimeters squared. Now the total surface area, the total surface area is equal to the sum. So if I add my front, back, top, bottom, and left, right, which is all 6 faces, I would get 64, goes to 64, oh, plus 24, which is 88. So my total surface area is 88 centimeters squared. Let's take a look at another example. So here, same idea. This is an object formed using boxes, prisms. And I will also use the same method. I will use the front, back. Okay. Top, bottom. Left, right. Once I found each, I'm going to do the sum, add them all together, and then I will get my surface area. So here we go. So if I were to look directly in front, I would see this face here and this face here. More specifically, if I were to, I would see only those 2 faces. So I would see something like this. I would see those 2 faces on top of each other. So one has a base of, they both have a base of 60 and a height of 20 each. So 6 times 20, so 2 times 6 is 12. And I have that twice. So my total surface area for the front will be 2400 centimeters squared. And because it's the front and the back, I double to get 4800 centimeters squared. Same idea for the top. If I were to look directly above, again, I would see this face here and that face there. So my top, bottom would look something like this. So I would have, again, 60 for the base and 20 for the height. So again, it would be the same as the front and the back, top and the bottom. So again, 2400. And I double that because I have the top and the bottom, so 4800 centimeters squared. Now finally, if I look at the left and the right side, I'm going to see this face, and this face. More specifically, I would see three faces like that. So then each face is 20 by 20. So each face is worth 400. 400. 400. So my total surface area would be, again, 1200 for the left side, and right side I double, so 2400 centimeters squared. So my total surface area is going to be the sum of the front, back, top, bottom, and the left, right. So if I do these two together, 48 plus 48, that's 9600 plus another 24. So another 24. I get 120. So 120 centimeters squared. Finally, example 3. So here it's the same idea. We're going to use the top, bottom, front, back, left, right. So let's get going. So front, back. So if I were to look directly ahead, now if I look ahead, I won't see this part here sticking out. I'm just going to see this face and this face here. So if I were to look directly ahead, I'm going to see still only this face here. Now, this is where a lot of kids don't understand. They think they have to take out this part. That's not true, because if I push that in, I'm going to see this in the front. So the front is actually going to be 60 by 20. 60 by 20. So 100 and 1200 meters squared. I double that because the back is the same. If I look in the back, it would be 60 by 20. So the front and the back is going to be 2400 meters squared. All right. Now, if I look at the top, okay? Now, because it's a building, we never calculate the surface area of the bottom because we know there's no bottom. So we just do the top because it's a building. So the top is going to look something like this. I have one huge rectangle and I have another rectangle. So I have two surface areas. So my top is going to be 60 by 30, which is 18 hundredths. And the other one is 20 by 20, which is 400. So my top, just my top, is 22 hundredths meters squared. Again, I don't do the bottom because it's a building. If it's a building, I do not do the bottom. All right, finally, the left and the right side. So here it's actually easier just to do this side here. I can see, so the left, right side. So it's going to be rectangular shape, the big side, and I'm going to have a little rectangle sticking out here. So here, this one here is 30 by 20. 30 by 20, which is 600 meters squared. And the smaller one is 10 by 20. 10 by 20, so 200. So the left side is 800. And remember, I have that twice, so I need to double that to get 1600. So my total surface area would be 24 plus 16, which is 40 hundredths, plus 22. So my total surface area would be 6200 meters squared. Now it says enlève la porte brun. So we just have one final step. We need to take away the brown door, which is 10 by 15, which is 150. So we just minus 150 to get a total surface area of 6,050 meters. So 6,050 meters squared. So it's always the same process, front, back, top, bottom, left, right. If it's a building, there's no bottom. Here's your practice. And don't forget to check your work behind the book.